Okay, so once again, I'm going to close these so that we can use those names again.
Dan, you look like you don't like it.
No, I'm with him. I really care about how long it takes to get.
Yes, well, that'll tell you how long.
That's right.
But
That's right.
determining whether you're meeting the standards is based on the equilibrium.
No,
Okay.
I understand.
Okay.
From a manager's,
Right.
my manager's standpoint, I really care about how long it takes to get down to a
Mhm.
particular point, which is a different kind of
A different question.
question.
Right.
Yeah.
Okay, so if I've opened up, let's reopen the control file. Open up the wqm_con.npt. And, you know, we've done this before now. So the initial conditions control is already binary because we read in the binary initial conditions from that other set from when we tried to equilibrate the model. So the initial conditions are binary, so that's fine. What we want to do is the initial conditions input, we need to give it the appropriate, you know, we need to give it a new set of input files. And I think that's an outputs, and we called it OPT3, right?
Did you change it?
Yeah, for this one, you know, we had OPT, OPT2, now we have OPT3. And I hope, let's come down to here, let's look. Yeah, and just for the sake, just for good practice, I'm going to go down to where we output initial conditions, and I'm going to make that 4. Okay, so now we're looping. We started with a set of completely fictitious uniform initial conditions. We looped a couple of times to equilibrate it to existing conditions. Now we're going to loop a couple of times to equilibrate it to a scenario, to a load reduction. And we'll save that one. We'll shrink this, and let's see if we can run this thing. Look at that. Okay. So people are following along?
Yeah, we don't need to ever recompile between these steps, do we?
No. No. You got a problem, Kyle? Or is it?
No.
Oh, okay. Well, I didn't know if you had a problem there or something like that. Okay. So what you're seeing is, you know, what you're seeing is sort of the general pattern that the Bay program follows when we run scenarios, you know. Okay. Everybody's executed? Good. Has your run finished?
It's running.
Okay, we give it a minute. Da, 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 da. Okay, we're ready? So we need to run our read snap file. What variable? Nitrate, we said, was 14. And the sediment variable is number 6, and away we go. And we open up our Excel file. And I'm going to go quick, but it's okay. I'll wait for catch-up. So once again, we're going to look at nitrate immediately downstream of the Susquehanna, and you see it's constant. I mean, it had equilibrated previously, but now we've got a complete 10-year equilibrated run. And if we look at the sediment model, And we're going to do the same thing here. And we see that the G2 nitrogen is also now equilibrated, so it's constant. So this would be, if this were the EPA running a management scenario, this is the run they would use. Okay, so they did a 10-year spin-up, equilibrated everything, then they run 10 years at the equal, using the equilibrated conditions as initial conditions. This is their scenario.
Quick question, Carl. Given the new G3, did the Bay program change because G3 takes so much longer to reach an equilibrium? It's a very small part of the SOP and whatever, but I'm just kind of curious.
We haven't.
Okay.
Okay, so we're going to do coffee and sugar in a couple of minutes, but before we do that, questions or comments? Now's the chance.
This was great, thank you.
Okay, so caffeine and sugar, about a 15-minute break. Richard, now, okay, so the next, as I mentioned, the next half, Richard's going to take over, and we'll do it up in the cloud. Let's say quarter of.
And one last question.
Go ahead.
Anyone that had trouble with any of the exercises, if you want any assistance during the break, just, raise your hand or let anyone around the side know, and we'll be able to take care of that.
What could be the possible causes for the negative salinity? The negative salinity is minor.
Numerical dispersion. It's a numerical. It's something numerical here. Probably what I would do, a couple of things to do. One is shorten the time step. That's a quick thing to do. Shorten the time step. Another one might be, remember that dirty word? What was the dirty word? Dispersion? Put a little dispersion in there.
So in this case, the theta was set to 0.7. The theta.
Okay. I suspect it is not.
Well, if I can make a quick comment.
Go ahead.
If you set the theta, just thinking about it, because it's not one is completely backward difference and guarantees positivity. If you were central differences, you don't guarantee positivity. And since 0.7 is in between, that might be the reason. Because you're at that cell, which is the land cell, so you're sort of using the upwind or favoring the upwind. You're not using the quickest. But because you're not fully upwind, you may have that risk because central difference of approximations get negative, can generate negative results.
I think
maybe that.
Interesting. It's a numerical artifact, and the thing is, what would we do about it? And just for a laugh, during the break, let's do some. In your control file, where it says, right now you're running, what is that? Those are seconds, so 864 second time step. Make that like 86.4. Crank it down, and let her rip while we're enjoying our coffee. And let's just see if you get that when we come back.
And if you do that, leave it at 864 and change your alpha to 1 instead of 0.7.
The theta.
The theta to 1.
Where is it?
I'm not
So
sure where.
we don't want to do the two at the same time.
No, but I want you could do it yours and then.
Okay, so I'm going to leave this, and I'm going to find theta.
Change it to 60 seconds.
Okay. But where the heck is my theta? All right, there's what ways of doing this.
Is it fully spelled out as THETA?
Yeah, I don't think it is. That's why I typed in THT.
Yeah, I noticed.
You think, we think,
Or you look for 0.7.
Yeah, right after quickest. HYD.
There it is. Oh, no, actually, it's 1 now.
Oh, it is
So
one.
it's already fully
So
implicit,
that
yeah.
means it's maybe a time step issue. Okay.
Yeah, well, we're gonna find out over break, okay? Tune in 10 minutes or so, and we'll see what happens. Okay, thanks, everybody, and see you at 1:15.